All right. So for today, all I have is a few questions. So I'm going to say, let's say that R is a region in the XY plane, whose area is B. If f of xy equals k for all xy in B or in R, then this double integral equals what? What is it? B times k, right? So f of xy is k. We would get that this is the double integral over our region of k times dA. And the double integral of dA over our region is just the area of the region. So we just get k times b. Area of the base. So what is f of xy equals k? What kind of surface would that be? What is it?
Oh, that
Z equals k. It's just a plane parallel to the xy plane, k units above the xy plane. All right, a couple more questions. Let's say we have, for the double integral over our region, we want to know if this is sometimes true, always true, or never true. F of x, y dA. We want to know, is this can this be greater than the area of R?
Yeah, it's not in the same units. That's like volume. It's units and the area is measured in squares.
So in quantity, in magnitude, can that double integral be greater than the magnitude of the region?
Yeah, it has to have a non-zero.
Unless
Right.
k is
Unless k is less than 1.
So
but greater than 0.
so is this always, sometimes, or never? Sometimes. And can we quantify sometimes a little more?
You can make a plane where it's 1.
I'd say usually, right?
Yeah.
Usually in magnitude.
Like 74%. I think numbers between 0 and 1, so sometimes.
And we've already answered this. Less than in magnitude the area of R? Not usually, but it can be, right?
Perhaps.
So we could say sometimes.
So what about the issue with units? Because
I'm just talking about the magnitude. Greater or smaller than in magnitude. And based on what we saw in the last time, if we have a plane at height at z equals 1/4, then the magnitude of that volume would be less than the magnitude of the area. How about equal?
Yeah, exactly.
sometimes.
Yeah. What did you say, Sam? Rarely.
You put it like exactly z equals 1. Like that's
Sometimes we could have z equals 1. So a plane height 1. So then the magnitudes would be the same.
function that has a positive and like a function that moves through the plane you're intersecting, so you have some positive area and some negative area?
It's possible, but the way we defined a double integral, we said the f of xy is greater than 0, greater than or equal to 0. So we're talking about things that are above the xy plane.
But if you did have that, you guys would happen, these things would happen more frequently.
Well, and it would depend on if you're just counting, if you're counting positive volume and negative volume, and then yes. But if you're just counting the magnitude of the volume, you're then right, right.
It's the same problem that you had
With areas, right, right. If you're talking about physical area, then you add them together. But if you talk about a positive charge and a negative charge, then you'd use the signs. All right. Here's a surprise.
Oh boy.
Surprise.
I don't know.
What?
What? Oh! We made it an integral.
Go get it, Dylan.
No.
No.
Can we go back? Need a little piece of paper or no?
Yeah.
Yeah, go
What?
get it.
Now I'm getting immediate brody, and that is it.
Wow, you're mean, Dylan.
1 over natural log y dy. So we say, well, let's see if we can change the order.
The thing is frozen.
Oh,
It's problem.
Whoa. There we go.
so we sketch this region, and we say, oh, y goes from e to the x to 10, and we realize that e to the x has an x-intercept at 1 there. So that would be at 0, 1, not down here. If on a test you drew your exponential function through the origin, but then did the other, you would lose a little bit of points for that, for doing something mathematically incorrect and saying it's correct. Yes, yes.
Okay, if I didn't exactly do that, I would say that a little bit is a no.
If you drew it like this, that looks like it
That
goes
is
through the
blatant.
origin to me. Yes.
What if you write
No.
x equals 1 or y equals 1 next to 9?
Yeah, 9 minus 0 would be 9. Just
But that's not the region. That's a different region. That's a different integral. And this is y equals 10, and this is y equals e to the x. So x is natural log y. This point is x equals natural log 10. So when we change our order, I'm going to erase this incorrect drawing. Or I could leave it. I'll redraw it down here like this. If this, and I'll just do
That has space. That's like
that looked like it possibly could go through 0, 1. There we go. And I'll say minus 1/2. And so we set this up again for our new order of integration. We have that y goes from 1 to 10, and x goes from 0 to natural log y. When we set our rectangles horizontally, 1 over natural log y, dx dy. And that turns into an easy integral, and we get 9. All right. So what we're going to do next is I have an activity that is a bunch of different regions, and we don't have to evaluate these. We're setting up the limits of integration based on how they've set up the iterated integrals and the region that they give you. So just a note on the notation on this sheet. For the first part, they write this. So, for example, the first one looks like this: blank to 4y. And they do this as f of x, y, this is a dy, and this is a dx. So this is the same as the way we would notate the integral 0 to 1, integral from 0 to 4y, or blank to 4y. F of x, y, dx, dy. So we're evaluating, we're setting up this integral first, and then we set up the second.
Why is dy over there? That means like parentheses are in the wrong place.
Yeah, because dy tells you when to stop doing integrals.
And it's just in a different,
That
it's
means
just,
not-
it's
that's
multiplication.
just, the integral into y.
It's multiplication, it's commutative.
But I see the integral into y, not
That's just the integral.
Dy times whatever you get here, this is a function of y. So it's commutative. So the purpose, what we're doing is filling in these blanks based on the region that they gave you. The second problem gives you an iterated integral that's set up and asks you to write a question about that integral. So you're supposed to describe, so if it were a question on a test and the student was supposed to set up the integral, you need to ask a question that would be appropriate for the integral that they've set up. The third one, if anyone who does the third one correctly and completely, will give a little bit of extra credit to. It's a nice, so it has to do with a triple iterated integral. You evaluate them the same way as a double iterated integral.
Oh, it's
But
X, Y, and Z.
it's x, y, and z, but you come up with a formula for the sum of 1 over n to the third from n equals 1 to infinity. So for today, our homework,
Wait, what? That's our entire.
No, right. Wow, it's all on short notes. Yeah, if you can give us some, I'll approve it.
all right, there.